Number 48, summation as n goes from 1 to infinity. 1 over 2 plus 1 over n to the n power. So we can do a little algebraic trick to rewrite the series as, so we write this as 2 plus 1 over n to the minus n power. We can use negative exponents. And then minus n power, we can use a different property of exponents to rewrite it as, we can break it up, 2 plus 1 over n to the minus 1 power, and then to the n power. Remember, the properties, you can combine these two by multiplying, so it's minus n, and then minus n power, we can make a positive by putting it at the bottom with the fraction, so that we get back this. Okay, why do we want to write it like this, though? Now, this series is to the n power, so which test is good to get rid of whole series to the n power? The root test. So let's try that. Limit as n goes to infinity to nth root of the absolute value of this guy. That's what this mess is over here. I just plugged it in. Okay, this nth root and this to n power would cancel, so you're left with 2 plus 1 over n to the minus 1 power. Take the limit as n goes to infinity of this. If it helps you out, put it as a positive exponent, so put this at the bottom of the fraction. 2 plus 1 over n at the bottom. Now, as n goes to infinity, this 1 over n would go to 0, so you're left with half. What does the root test say? It's the same conclusions as the ratio test. So since this is half, which is less than 1, this series absolutely converges, which means it converges.